Today we're going to talk about multiple events. So if two independent events occur, the possible outcomes, we can put them into a table. Independent means that they are not related. The outcome of one won't affect the other. They're two events that could happen before each other. There is no relationship between the events. So the table can look like this if we're, for example, rolling a die and then flipping a coin. So we have the die up as one heading and the coin as the other. So the possible outcomes of the die are 1 to 6, and they're each of the different columns, and the possible outcomes for flipping the coin are heads and tails. So once we have put all of the different possible outcomes for each of them, we can see what the possible combinations can be. So the possible combinations could be flipping a head and rolling a 1, flipping a tail and rolling a 3, and we can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes here. 2 times 6. So there's two possible outcomes for the coin, 6 possible outcomes for the die, so there's 2 times 6, 12 possible outcomes within here. Now, just remembering, the probability of an event occurring is the number of outcomes where the event occurs divided by the total possible outcomes. So if we were looking at what the probability of flipping a head and rolling a 3 is, there's only one possible outcome where flipping a head and rolling a 3 occurs out of 12, so the probability would be 1/12. If we were looking for the probability of flipping a coin and rolling a number greater than 3, the numbers greater than 3 are 4, 5 and 6, and flipping a head would be these 3 outcomes. So there are 3 outcomes that get ahead and get a number that is bigger than 3, so that would be 3 out of 12 or 1/4. Having a look at an example, if we've got a spinner with the numbers 1 to 3 that is spun, and a card is chosen at random out of a box from the letters A, T, H and S, so there are 4 cards in this scenario, we're asked to draw a table of the sample space. Answer how many outcomes in total does the experiment have? Find the probability of spinning a 2 and drawing an S, and find the probability of an odd number being spun and the letter H being chosen. So here we've got our sample space here. We've put the numbers that could be possibly spun on as our rows, and the columns are the letters that could possibly be drawn. So we can see that there are 4 letters and 3 numbers that can be spun, so the number of total outcomes is 4 times 3, which is 12 possible outcomes in our table here. The probability of spinning a 2 and drawing an S, 2S, there is only one number that is 2S here, or one outcome out of the possible 12 outcomes here that is 2S. So the probability is going to be 1 out of the total of 12 possible outcomes. The probability of spinning an odd number and drawing out an H, the odd numbers that we've got are 1 and 3, and the H's here, so we've got 1H and 3H. They're the only 2 possible outcomes out of our 12. So it's 2 possible outcomes out of 12, so that's 1/6.